Hello students, welcome to section 19. In this section will be covering examples from the remaining word problems. Now, to page 22, example number 3. We have a boat that travels 16 kilometers upstream and 24 kilometers downstream in 6 hours. And in the second case, we have the same boat traveling 36 kilometers upstream and 48 kilometers downstream in 13 hours. Now, the first two terms that we need to understand is what is upstream and what is downstream. So let's say that I am trying to walk down a road and I'm moving in this direction. So I have some speed, let's say x, and then suddenly wind blows up in my face, which is in this direction. So what will happen is that I'll start to slow down, or at least I'll have some force against me. That means the y direction is opposing me. So this related to my speed becomes minus y. So when these two add up, my speed becomes x minus y, or if you want to say this in simpler terms, is that my speed starts to get reducing once I move against the wind. Now, let's say that the wind, instead of coming from this side, instead of coming from here, goes in this direction. So let's say the wind is blowing in this direction. That means the wind and my movement direction are the same. So this is in the same direction as me, therefore this value becomes plus y. That means I am moving with the wind, therefore my speed becomes x plus y. As you all must have noticed, whenever you walk and if the wind is blowing in your back, your speed starts to get increased, or at least you start feeling lighter, or you feel that it's easier to walk fast. That is because the wind speed is helping you to move forward. Therefore, upstream means I'm going against the wind. That means this value is upstream, and downstream means I'm going with the wind. So this value is downstream. So now back to our example, we have a boat traveling 16 kilometers upstream. So let's say that the boat speed is x and let's say the current speed is y. Now this is my river. In the first case, I'm going in this direction, so this is x, and the river is in this direction, and the river is in this direction, so this is y. So this is my upstream, and in the second case I'm going in this direction and the river is also in this, and the river is also in this direction. This is y, this is x. So my upstream speed is equals to x minus y, and my downstream speed is equals to x plus y. Now these are two very important values that we are going to use. Now coming back to our statement, our first statement says that boat travels 16 kilometers upstream and 24 kilometers downstream in 6 hours. So let's try to evaluate this. That means I'm going 16 kilometers in this direction. So this is 16 kilometers, and then I'm going 24 kilometers in this direction. And so the total distance covered here is, so the total distance covered is equals to upstream distance plus downstream distance, which is equals to 16 plus 24, which is equals to 40 kilometers. Now, the total time that is required to cover 40 kilometers is 6 hours. Now, I know the total time taken, but I do not know the individual times of upstream time taken and downstream time taken. So I can say total time 6 hours is equals to upstream time required plus downstream time required, which is equals to 6 hours. Now, we have to use one particular concept from physics that is very important, that is distance is equals to speed into time. Now, as we can see, we used our equation in terms of time over here. We used our equation in terms of time. Therefore, I want my relation to be in terms of time. So, therefore, I'm going to write time as distance divided by speed. So, coming back to our equation, our upstream time required will be equal to upstream time is equals to upstream distance divided by upstream speed. So which is equals to upstream distance is 16 kilometers, and our upstream speed is x minus y kilometers per hour. So coming back to our upstream time, this is 16 divided by x minus y. Now for our downstream time. So downstream time is equals to downstream distance, which is 24 kilometers, and my downstream speed, which is x plus y. So my downstream time becomes 24 divided by x plus y. Now coming back to our original equation, that upstream time required plus downstream time required is equals to 6 hours. So we have to use this equation to write down our actual values in terms of x and y. So let's start writing. We have upstream speed, upstream time plus downstream time is equals to 6. So our downstream or upstream time is 16 divided by x minus y. This is 16 divided by x minus y, and our downstream time is 24 divided by x plus y, which is equals to 6. This is my equation number 1. Now, once I get this equation number 1, I can similarly make equation number 2. So in equation number 2, the statement says that the same boat travels 36 kilometers upstream. Again, I have to use the same equation, upstream time plus downstream time is equals to, in second equation, so or we can say the second statement, the total time taken is 13 hours. So here I write second case is total time is equals to 13 hours. So once I have total time is equals to 13 hours, this implies that upstream time plus downstream time is equals to 13. Now, as we had the values for upstream time as upstream distance divided by upstream speed, similarly in this case, we are going to write upstream distance divided by upstream time. I am using short forms just to be quick. You do not have to use short forms in your classwork copies. This will not give you full marks. Then I here have downstream time distance divided by downstream time. This is equals to 30. Now in the second case, my upstream distance is 36 kilometers. So this is 36. My upstream time will be the same, is x minus y, plus downstream distance is 48 kilometers, and my downstream time will be the same, which is x plus y is equals to 13. Now once I get this, I have both my equations. This is my equation number 2. So here I have 16 divided by x minus y plus 24 divided by x plus y is equals to 6. This is equation number 1. Then here I have 36 divided by x minus y plus 48 divided by x plus y, which is equals to 13. This is equation number 2. Now, how to solve this linear equation? As we have seen from practice set 1.4, if the unknown variables are in the denominator, all we have to do is replace them by some numerator new unknown variables. So I'll be using 1 upon x minus y is equals to m, and 1 upon x plus y is equals to n. So this implies I have 16m plus 24n is equals to 6, and 36m plus 48n is equals to 30. This is my equation number 3. This is equation number 4. I'm using elimination method, so I'll multiply equation number 3 by 2. That will give me 32m plus 48n is equals to 12. This is my new equation number 5. Now I'll subtract 4 from 5. So I have 32m plus 48n is equals to 12 minus 36m plus 48n is equals to 13. So minus sign changes the sign everything inside. This is minus, and this is minus. 32 minus 36 is minus 4m. This is 0, and this is equals to minus 1. This implies that minus 4m is equals to minus 1, or m is equals to 1 by 4. When I put m equals to 1 by 4 in any of the equation, I'll put in equation number 3. This gives me 16 into 1 by 4 plus 24n is equals to 6, which implies 4 plus 24n is equals to 6, which implies 24n is equals to 6 minus 4, which implies 24n is equals to 2, and therefore I have n is equals to 1 by 12. Highlighting our answers is important. So my n value is this, my m value is this. Now m is equals to 1 upon x minus y, which is equals to, our value for m is 1 by 4, and n is equals to 1 upon x plus y, which is equals to 1 upon 12. So I have my values as x minus y is equals to 4 and x plus y is equals to 12. If you start solving this equation, you will get x is equals to 8 kilometers per hour and y is equals to 4 kilometers per hour. I hope this question was easy to understand. If you have any problems, just message me and I'll help you out again. This section will end here. In the next section, we'll cover the remaining solved examples and then we'll move on to our practice set 1.5. Thank you.